highlight our laws of logarithms. And our first log law is related to the exponent law that says if you are multiplying powers with the same base, you can add the exponents. Logs work backwards, so logs sort of say if you are adding logs with the same base, you could write them as multiplying inside the logarithm. So it's the same idea of a law, just written in the terms of logarithms. Adding two logarithms with the same base is like multiplying them inside. And what we're going to do with our log laws is sometimes we're going to, just like an identity, sometimes you're going to have the left-hand side and want to write it as the right-hand side. And sometimes you have the right-hand side and are going to want to write it as the left-hand side. There's going to be a formula that you can switch back and forth between. And depending on the question, sometimes it's useful to go from the left side to the right side. And some equations, it's going to be useful to go from the right side to the left side. What we do in section 5.5 is we just get good at working with the laws, and then later on in this unit we see where does this new skill that we have, where is it useful. Second log law is the quotient law, which is related to, right, your power law that says if you have a power divided by a power and they both have the same base, then you can subtract. And in log laws, it says if you are subtracting two logs with the same base, that's the same as those numbers divided inside of a single log. And our final exponent law if you have an exponent or a power to a power, then you multiply the exponents together. We have the same thing working backwards. If you're multiplying by a number outside of a logarithm, you can move that number inside as an exponent within the logarithm. And if you have an exponent within a logarithm, you can always move that exponent out in front. I think that's easy to see with some of the mental math we've done already. Okay? First of all, I'm going to give you ones that you know. What is log 2 of 8? What exponent would make this work? Good. 3. What is, here's a log 2 of 2. What exponent would make that work? 1. Did you know that you could write 8 as 2 cubed? And this new log law says anytime you have an exponent, you can bring that exponent out in front. Oops, an equal sign. I bring the 3 out in front, I'd get 3 log 2 of 2. We know log 2 of 2 is 1. We know that 3 times 1, hopefully, is 3. And so we can see that these are the same using this new log law. So now what we're going to do is we're going to take these 3 new log laws and see if we can use them. And some questions are going to ask us to take the right-hand side and switch it to the left side. And some questions are going to ask us to take the left side and switch it to the right side. And right now, it might feel like we're just flipping back and forth between things without a reason. And that's true. We're going to be doing it today without a reason, but it sets the foundation for doing some mathematics later on where we need to be good at these skills of switching these formulas back and forth. So example 1 says simplify. We're going to write a little note here. In logarithms, simplify means write as a single logarithm. So in A, we have 2 logarithms. That is not considered simplified. In B, we have a 5 in front of the logarithm. That means you have 5 logarithms, not a single logarithm. That is not considered simplified. In other words, in our formulas, the left-hand side is considered the simplified side. The right-hand side is considered the expanded or not simplified side. So what we have in each of these questions is we have the right-hand side of those formulas. In part A, you have log 7 plus log 8. Is there a log law that says if you're adding on the right-hand side? Yes. If you're adding is the same as multiplying inside the logarithm, which will give us log of 56. I'm going to ask someone to do this mental math. I need to know if someone doesn't want to do it. Put up your hand. Everybody wants to do it? You don't want to, okay. Cam doesn't want to do it. Perfect. Pick someone to do it. You get to pick the volunteer. No, he put his hand up first. Chase, you are going to tell us, using your mental math skills, what the answer to log of 56 is, but you only have to get the first digit right. The rest is close, it's close enough. So, we are going to try and do mental math of what is log of 56. And do you guys remember when it's a log, what base is here that's not written? 10. Okay, there's your hint. What is that equal to? About, approximation. $1.5. Excellent estimation. Would you agree? Because we know that log 10 of 10 is 1 and log 10 of 100 is 2, and 56 is somewhere between 1 and 2, because 56 is between 10 and 100. So yes, 1.5. We don't know if a 0.5 is exactly right. We could check our calculator. Might be 1.6, might be 1.4, but I just wanted one digit right. Perfectly fine. Okay, second one. B. We have 5 log of 2. Does that match up on the right-hand side of one of our new log laws? Yes. If you have a number out in front of a logarithm, that allows you to put that number in as an exponent, and 2 to the 5 is 32. Chase, you get to pick our next volunteer. To estimate this, they have to get at least one digit correct. Liam. Log of 32 would be about 1.3. Seems like a good. The 1 is definitely right. We don't know for sure if the 0.3. It should be, if we guess 1.5 for the 56, it makes sense that we would guess less for the 32. Okay, and the last one. We have a log minus a log. That shows up as one of our formulas and says if you're subtracting 2 logs, you can write it as a single logarithm by dividing. So we get 80 over 16, which comes out to log of 5. Mental math. Liam, who are you going to pick? Braden. 0.5. Seems like a good example because we know that log 10 of 1 is 0. Log 10 of 10 is 1. 5 is between those two numbers, between 1 and 10. So 0.5, an excellent estimation. Questions you can circle for practice on this one are 4 and 12.